It's my privilege to warmly welcome all of you in the afternoon part of today's conference. I hope that you managed to rest a bit, maybe chat with some other people, maybe get some fresh air and eat something. But I still hope that you're a bit hungry, hungry to learn more. If that's the case, then just let us jump into the first speaker and the first talk. Piotr Gaczkowski has been coding since he was 10 years old. He started quite early. He aims to create simple solutions for everyday problems and automate everything that is boring. This is the statement you can find on his website. On top of that, we can say that Piotr is also an author of several articles, courses, and a book. Today, he will share with us his knowledge and experience when it comes to microservices versus monoliths. Why is that topic such important in IT industry? Well, let me just point you one information. According to some analysts, microservices are projected to grow globally at a 22% rate between 2019 and 2025. It means that we're somewhere in the middle of this period. Many engineering teams sooner or later will be in a position to decide what architecture they will choose. Is there a thorn? Is there a rose without a thorn? Let us carefully listen to Piotr and find out. Piotr, the stage is yours.
Thank you very much. Hello, everyone. It's a bit weird that you probably see me and hear me, but I don't see you and hear you. But at least we're here, so we can start. As you already know, my name is Piotr Gaczkowski. If you find the information that I share here useful, you can follow me on GitHub, on Twitter, check my website. The slides for this talk should also be published at the link that I'm sharing right now, so you can follow along or get back to it later. And what I would like to talk today about is modern architecture and fashion. As you know, fashion comes and goes, but the features stay. The pants that you are wearing today may look totally different from what our parents were wearing, but they still have the same basic principles. They have the pockets to hold our precious smartphones, etc. People in tech are especially funny because they're all about taking rational decisions that are based on merit, and we don't want to follow our instincts here. But then they go all emotional and jump on the fashion bandwagon saying, ooh, this Kubernetes stuff, it's so shiny, I want it. It's natural that we all look at the role models. And the role models of our industry are, for example, Spotify, with their notion of tribes and squads, which they are, by the way, not using, but the fashion still holds. There's Google with Kubernetes and Golang. I heard the question many times, should we go Kubernetes? Should we switch our architecture and start using Golang because everybody is using that? You can thank Google for this fashion statement. And there's Netflix with microservices. So what are microservices? Not yet, just a moment. First, let me paint a bigger picture, because we are talking about architecture, right? Architecture traditionally was about blueprints and mortar. First, architect prepared some blueprints, figured out all the hard parts, and then it was to the builders to lay bricks, put some mortar, do the boring stuff, the stuff that didn't require much thought. But builders have thousands of years of experience, which led to established best practices. They know what to do so that the building don't fall on their heads, especially if they are inside the building. On the other hand, in the software world, we have so far around 70 years of experience, which is less than one lifespan. We didn't have much time to figure out the best practices, and those that we figured out. Some of them right now are considered anti-patterns. So yeah, this is something that's worth mentioning. There's no piece of software in existence, I believe, that is older than 2 human lifetimes, whereas we can find buildings that were built several thousand years ago and they still stand. So there's this nice thing that I like to quote called Conway's law. I'm fairly certain a lot of you already know it, but if you don't, Conway said somewhere in the 70s, I believe, that any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. You can keep that in your notes because this will come in handy at least several times. So about software architecture. What's software architecture and what's so special about software architecture? First of all, a brief history. At the beginning of software architecture, there was nothing but a monolith. We had a single piece of software written somewhere on the perforated card, which you put into the machine. The machine were doing some processing, then it spit out some data that were either useful or if you made an error, not that useful. That was all. Then there came the operating system, which made it easier to write programs because a lot of the stuff that you would normally have to write on your own was handled by this underlying operating system. The operating system also came with some system libraries, some independent programs that we can execute, but all of them were still more or less monoliths, monolithical software. So will I explain what monoliths are now? Not yet, bear with me just a moment more. What are the challenges of software architecture? First of all, we're not building cathedrals. There is something called leaky abstraction, which means that the abstraction that we want to put that, okay, so this piece of software, it looks basically like a building, right? So we can assume that it will behave in a similar manner. If we use the same methods we use for raising buildings, we could use it for building software. Leaky abstractions are when the principal abstraction just doesn't hold. We see a lot of things that are not that straightforward. And we are not building cathedrals. We're building quickly mutating transformers that live in a world that's evolving at breakneck speed. If you're building a cathedral, you're probably choosing a place that is on solid ground, laid with some pavement, for example, something that is guaranteed to be there for the next millennium or so. Software is more like sandcastles that we try to put on a swamp. So not only the material doesn't hold very well, but also the ground is rather not trustworthy. The main abstraction from building cathedrals with the blueprints and then mortar is the waterfall process. And unfortunately, waterfall process is not agile enough if we want to, get these mutating transformers where we want them to be. And monoliths are basically software equivalents of cathedrals. They are rather solid, but you probably wouldn't like to imagine, a cathedral being reworked every week or so. Monoliths come from the name monoliths, which means one stone. And this is basically what they do. They are not easy to modify. And if the market doesn't want what you have, you basically need to get a new monolith. Of course, with software, it's easier than with actual rocks because we can put some effort into getting a new monolith instead of finding a new one in the query. But still, it takes a lot of time and energy to do that. So going with monoliths is not sustainable if fashion changes quickly, and fashion changes quickly. So the main challenges here are one feature change is entire monolith change. You can't replace one feature without building everything, integrating everything, and putting basically a new cathedral in the place of the original. Therefore, it's better to not change it too often because of all the required work that you need to do. It's not just costly, but it is also time consuming. But fashion changes. So what can we do about it? And here's how this talk is connected to the general idea of Agile by example. We have the Agile processes that are about features and market needs. So basically, Agile is about being fashionable and about releasing early and releasing often. So can you be Agile with monoliths? The short answer is yes, you can. Especially if you're Obelix and you have superhuman powers, no problem with that. Interestingly, some big players are okay with monoliths. It's not that all our role models are going microservices crazy. For example, I'm not sure how current this information is. I know this was the case at least several years ago. Maybe something changed in the meantime. But Facebook used to use a single monolithic application, single binary, just one file containing the entirety of Facebook. That was several gigabytes of data, and they needed to transfer it via network to several data centers around the entire world. So I imagine that their deployment process looked something like that. They just hired somebody with superhuman strength. They gave them the magic potion, and they could work with that. If you have superhuman powers, if you have magic potion, then being agile with monoliths is probably fine. So what are the risks involved in trying to be agile with monoliths? Updating one feature may break the entire system. For Facebook, it is easy because they're using a lot of smoke and mirrors. They have load balancers that only point a tiny fraction of the traffic to the newly deployed monoliths. So they can see pretty early if the things are right or wrong. But in general, this is a rather complicated challenge to overcome. So what other methods are there to become more agile? First of all, if we want to develop independent features that answer the current fashion needs, we require independent teams. Then independent teams require independent subsystems to work on. Somebody is responsible, for example, for the volume control. Somebody else is responsible for handling the audio inputs. Somebody else is responsible for the output. These have to be as much unrelated to each other as possible. Then each subsystem is tested and integrated. And considering they're loosely coupled, they can be released independently. So we can change, for example, the volume control subsystem without touching anything else, more or less. So the Conway's law comes in here with a warning, because systems follow organizational structure. So you need to break the monolith into separate features and then connect them together if you want to be truly agile, truly independent, truly care about single features for single teams. And this, my dear friends, is what microservices are about. So microservices are independent, loosely coupled pieces of software. Each of them is responsible for a single feature. Basically, if you're familiar with Unix philosophy, this is the Unix philosophy in a distributed world. Unix philosophy means do one thing and do it well. If a software can just filter text, then let it filter text and not add something to it, not edit it, not do anything that's not directly its main purpose. Microservices are definitely more agile than monoliths because there's less need to sync with other teams. You basically can write a contract at the beginning of work, and this contract stays for as long as you need it. If you find that your team found something that the contract doesn't hold, you can then sync with others to update the contract and start working with the updated contract. But in the meantime, you can release on your own schedule. The other team may release on their own schedule. They may release once every half a year. You may release once every few hours. That's fine. So this means that for agile companies, microservices are definitely better than monoliths, right? And yes, as you can probably imagine, I'm not asking this question because the answer is a simple yes. This is what all the trendy magazines want us to believe. This is what is most often talked about when it comes to microservices, but it's not the entire truth. So microservices definitely have a lot of great stuff for them. You can choose the tools that are appropriate for the job. So for example, if you have a team that is working closely with the front end, they can use, for example, Node.js. For the more backend stuff, people may be running Golang because that's what's more performant in this case. If there is some machine learning AI stuff, you may find it easier to hire engineers with Python experience. So this portion of your product will be written in Python. You can use whatever you want when it makes sense. You don't need to have the entire code base written in a single language. You have autonomous teams. Each team can make their own technical decisions for themselves, and most of the time, this wouldn't hurt anybody else. You can have your own coding standard. That's fine. This way, teams know their domain and their frameworks, but not necessarily the entire environment that they work with, which may be good, which may be bad. You can have continuous deployment with microservices because it is easier to change tiny parts than to change the entire several gigabytes binary. You can have shorter feedback loop because if you release often, you can learn from your customers if what you released is actually what they need or not. If it's not, you can iterate and deliver new features. This gives us more space for experiments, and that's basically what we want because we don't always know what will be fashionable next week. We want to experiment, figure out if that's what people need, else just adapt to the current fashion. So what are the costs then? And these are some of the features of microservices that designers won't tell you about. First of all, organizational overhead. When I've mentioned autonomous teams, it probably looked quite cute to you. But the thing is that each of the team needs to have basically a full stack of responsibilities inside it. You need to have QA in each of the teams. You need to have somebody for security in each of the teams. You need to have product owners. You need to have Scrum Masters for each of the independent features. This is quite a lot of people, actually. Then there's technological overhead, because if everything is loosely coupled, it has to communicate somehow. So we have network bandwidth, we have the protocols that we want to use, which mean that there is more processing power required, more memory required, more data storage required, because, for example, each microservice can have its own database. So suddenly we are not just running one database with everything, but data is everywhere, and it takes up more space because of that. And finally, multiple tool chains mean there's less overall understanding of what's going on. So yeah, I've seen things like one team using some esoteric language that they figured would be fine for their purpose. But when the entire 2 or 3 person team left, nobody could pick up this microservice, and basically it went, yeah, it became obsoleted and replaced with a new one written in something that other people knew. This wasn't that bad because there were contracts, there was a clear API of the service. It doesn't require a full reverse engineering, but still, this was quite a challenge. So, shall we all switch to microservices now that we know what are the costs and what are the benefits? Probably. But first, there's Mr. Conway with his law. 2 good questions to ask yourself before going to the ultimate, shall we switch to microservices? First of all, is your organizational structure ready for microservices? Because if you have Monolith right now and the structure is basically looking like one would for a monolith application, especially with some remnants of waterfall processes, then you won't get microservices. What you'll get is called distributed monolith, and it's a flying disaster. So the distributed monolith looks like microservices because you have several different programs working together, but instead of them being loosely coupled, they are strongly coupled, and a change in one subsystem requires changes and synchronous changes of several different ones. So you get all the counts of monoliths, but with all the counts of microservices. You don't get the benefits of microservices, sorry, and you also lose all the benefits from monoliths, because monoliths have their benefits. Lots of overhead, no agility, lots of headache. So if you want to go with microservices, figure out if you can change your organizational structure first. If you can't, you are probably better off trying to figure out how to get better with monoliths. One piece of advice here that might be relevant: instead of breaking the monolith into tiny pieces and then trying to connect them together in one go, instead you can focus on adding new features as separate microservices. So if you're implementing anything that hasn't been done before, do it on the side, do it apart from the original monolith. This way you start introducing microservices, you can figure out how to adapt your organizational structure for that. You can figure out good processes that work in your organization. And then with time, you can start switching the existing features into separate microservices. Less risk involved this way, more space for experiment. That's good. So in short, following role models blindly can be harmful. It's cool that Netflix uses microservices, but first we should ask ourselves what problems are they solving and whether they have the same problems that we are solving in our organization with our product. So the second question is, the organizational structure is fine, cool, but can you afford switching to microservices? And I mean it in the monetary sense. So for the big players, hiring a lot of domain experts for security, for QA, for all the Agile related positions, for front end, for back end, whatever, is not a big problem. They usually have high margins on their products, so they can hire a lot of people in a huge organization, even if there is some significant downtime from a bunch of employees. That's not a problem. As long as everything is predictable, that's totally fine. So the organizational overhead is not that scary to the big players. What about technical overhead? That's also easy. For the big ones like Facebook, Google, Apple, if they have overhead, they just buy more machines. The machines are usually peanuts when you're dealing with, billions of dollars of revenue. You just put out another data center, then another, then another. That's cool. That's totally fine. We're not concerned with that. So basically for them, both of these costs are marginal, or at least not that significant, while the advantage is really big because they get quicker releases, shorter feedback loop. All of that leads to more revenue, and it goes on and on and on in a happy cycle. For smaller apps or smaller companies, these costs may be significant. So if your entire team is like 5 people and you want to split this team so it works on 3 microservices, then probably you need to hire at least 5 more people, maybe 10. So your costs go quite high. And the advantages are not that pronounced. You don't necessarily get much quicker releases. The revenue may not grow as quickly as with the bigger players. So this is something to definitely think about. So let me reiterate. If you want to know if you should switch to microservices, first of all, ask yourself if you can change your organizational structure and how can you do it. Starting small with new features being added on top of the current monolith is a good way to do it. You can learn from that, you can adapt, you can provide processes, you can start developing your own best practices this way. Second, use the calculator. Understand what costs may be involved in migrating to microservices. What would be the technical overhead? If you're currently sweating each time you get a bill from the cloud provider, then most probably you, at least at this point, can't afford migrating from the monolith to microservices. Of course, there are always exceptions from the rules because a lot of monoliths may be suboptimal. They might not use the resources that they have in the best way. If you have a single monolith that needs to run on a very, very big machine and a single machine, because somebody is buying, I don't know, let's say peanuts, and not buying anything else, this means you are basically subsidizing peanut buyers. If you have the same product, but written using microservices, you only need to scale microservices responsible for the peanut buyers and keep everything else intact. So the bill might actually be a lot lower than with the monolith. There are rules, there are exceptions, there are more exceptions. Think for yourself and figure out what's best for you. I know that a lot of people expect some silver bullets from the conference talks. I'm sorry, I don't deliver here, but I hope at least that these will help you make your own decisions and get better at what you're doing. This way, you could start experimenting on your own. So what I would advise is learn from the leaders, but understand their challenges. Understand why they came up with a particular solution and not just try to go with the solution thinking that you have exactly the same problems as they have. Google might be using Golang for everything they do, not because Golang is the best choice everywhere, but because they can handle the errors that they've seen in their organizational structure in the best possible way. Admitting you're facing different challenges, understanding the challenges that you're facing and comparing them to others is the crucial stuff. When you achieve that, you can adapt what others are doing into your own challenges, use it in your own products, and be happy with that. So a friend of mine once said that people like to mistake Agile with no architecture because we just want to move fast, break things, and experiment. But doing this without a good architecture is, well, maybe not hard, but it may lead to chaos and a lot of tears in the long run. Instead, if your architecture permits running fast and breaking things, this is a much better solution. So if you think that Agile should not be concerned with software architecture, better think again. And I would like to wish you that your architecture will follow the current fashion and that you'll be able to adapt to the changing market. If you're interested in software architecture, in the stuff that I've been talking about, in the microservices, the monoliths, and all the other stuff, you can check out the book that was mentioned at the beginning. This was released in April of this year, so it's not yet totally deprecated. Some of the stuff that's there is still relevant today. Unfortunately, even at the process of editing it, we had to make some last-minute changes because the entire world changed. So you see, even a simple process of writing a book falls prey to the fashion changing around us. And that would be it from my side. If you have any questions, I'm here to answer them. Thank you.
Thank you very much, Piotr, for this very thought-provoking speech. Thank you very much for it. Obviously, we have a few questions from our audience, so maybe let's start straight from this point. Maybe first question. You covered it somehow, but Any advice on how to prepare the organizational structure for microservices? Are there any hints or tips you would recommend?
Yeah, so what I've covered in the talk is like the main tip that I would suggest to using. Start with something small, figure out how to deal with it, and then move on forward. It might be just new features, but if you don't have any new features, like totally new, you can start with replacing a single thing that you can safely say that is how to say it, safe to break out from the monolith. So basically, that is as little depending on the other features as possible. Starting with that can help you basically change one piece of the organizational structure. And if you start with that, others will probably follow. So that's what I would say here.
Awesome. Thanks a lot for this tip. Then yet another question also touching your talk. What's a big versus small player when it comes to the question of whether to move to microservices, whether the move to microservices makes sense?
Okay, so it's not a question of what's big or small. I didn't want to make this, like quantifiable answer. The big player is somebody who has something. I left it open on purpose because I would like everyone to think if they believe they are, big players or small players. Basically, no. Let me put it this way. I've used the big player versus small player just to show that people who are not in the most glamorous companies that we look forward to often feel that they need to follow their footsteps, which is not the case. They are fighting with their own problems. We are fighting with our own problems. We don't necessarily need to, feel like we are not modern enough because we are not dealing with the stuff they do. It's something that we might be scared of because, okay, we are not using containers. That's very bad. Everybody's using containers. But if we are fine with what we have, we should be grateful for that and just go with that. So this was the distinction that I had in mind. But to answer the question, I've also mentioned that smaller apps may not benefit from microservices. So it's more of a question of how much overhead you need to introduce on top of what you already have. If you have 5 people and your application is, I don't know, running on the smallest machine that's available at your cloud provider, then probably breaking it down further doesn't make much sense. But if you are constantly calling your cloud provider and saying, hey, your biggest machines, they're just not good enough. Can we have something bigger? Yeah, this might be a call to action that you should rethink your software architecture. So that's my opinion on that part.
Okay, thanks a lot for clarifying this. Ready for another tricky question? So here it comes. Okay. Some engineers believe that each microservice should have no knowledge of the microservices around it. I think this is the principle in general. That does not seem to be practical in many cases. How about choosing a middle way, mini services? You didn't speak about mini services, but what is your point of view on that matter?
Yes, this is a very interesting question. A lot of people went crazy about microservices at first, but then realized that they come with a price. And then started talking about mini services, or I've also heard the name macro services instead of microservices. And yeah, these are all great great examples. It's a great pattern to follow. You don't necessarily need to have each feature available as a standalone subsystem. Some of them may be grouped together and released together if it makes sense. Microservices make the most sense when you actually have a lot of things that are more or less unrelated to each other, and you, for example, want to have different release cycles, you want to run different experiments on them, then it's perfectly fine. For most purposes, I think the approach that you suggested, mini services, so breaking your monolith down into like the regular rocks, not just gravel, is perfectly valid.
Awesome, thanks a lot. So I think that in general, many teams have this difficulty to understand, is this really micro thing? How can we go to this micro level? Sometimes when having monolith, it's really hard to really go into this direction because of the limitations we have. Okay, yet another question. Agile is mostly associated with emergent architecture. Do you think going for microservices makes it easier?
Nice. I don't have a straight answer for that. So I'll start with rephrasing what I've said before, that emergent architecture, as long as it's a well thought out architecture and not just a synonym for we'll just throw a bunch of stuff together and see if it sticks, is definitely the way to go. We would like to have some general vision of what we want to achieve, but then experiment freely along the way. Microservices, because they are quite small and quite, agile, can help with doing these experiments. So I think this should be, this should be a good approach, but I'm not necessarily saying that this is like the only approach or the best approach.
Okay, thank you very much for answering this question, tricky one. And staying in the tricky question zone, I have also a statement. Yeah, apologies for that. I specifically asked for a question saying that there are no bad questions, only tricky ones, but that's actually your problem. I mean, you're Piotr. Okay, so another thing.
I'm here for that.
I think that calling how software is structured architecture was a mistake, as this term came loaded with association from civil engineering. Do you think that's really a bad name for architecture, software architecture? Would you propose something different, Piotr?
I have to say, I haven't really thought about it before, but I totally agree with that. This is the kind of a leaky abstraction that I was mentioning before. It's totally loaded with civil engineering, and people writing software are usually called software engineers, but they are not put to the same scrutiny as civil engineers, for example, are when they have certain rules that they are required to follow in order to make sure that the buildings, the bridges won't collapse. We are basically permitted to do whatever we want most of the time, unless it's like a highly regulated sector like aviation, banking, something like that. And this architecture thingy doesn't really hold well. There are some points that are relevant. Probably when the term was coined like 50 years ago or so, it made more sense. Nowadays, it makes less and less sense, I would say. But honestly, I can't think of any better abstraction that we can use here. So yeah, that's that, unless somebody comes up with something much better, I guess we are still stuck with software architecture and need to fight with all the stuff that doesn't relate.
Okay, Andy actually suggested that going simple is the best thing, so structure would be the better name than architecture, in his opinion.
Yes, yes, yes. I think that structure could be more fitting.
Okay, maybe this will begin the change. I mean, this conference and this discussion. Let's see how that goes.
That would be cool.
Yeah, it should start somewhere. Okay, we have yet another question, also very interesting. So what do you think about joining multiple domain contexts into one microservice?
Okay, I'm not sure if I understand the question correctly, but if we are talking about business domains, then I would assume these all should be handled separately. So definitely we don't want things related to several business use cases in a single microservice. If it's a microservice that is abstracting something else, so for example, we have a product that is I don't know, sending some postcards to people, sending some flyers, some promotional stuff to people. And then we can have one microservices that is connecting with our post office or courier or whatever, that will handle all these use cases, but each of them should still be handled by a separate microservice. Otherwise, we may end up with something that is not doing one thing, but doing several things and trying to figure out which hat it's wearing at the given moment.
Okay, thanks a lot for this answer as well. So let's finish maybe this Q&A session with the last question. Very interesting. Piotr, how to reasonably approach testing of microservices, especially security testing?
Oh, yes, this is very interesting one. So there are several levels to that. And this is one of the overheads that I think I forgot to mention. That first of all, we need to test all the microservices like in separation, whether they're doing what they're intended to do, whether they are, secure enough, all of that. And then we need to do the integration testing with all the other services. So for example, if one service is sending some messages to our already tested service, we need to make sure that it behaves properly. Security is especially tricky since we are not just concerned with microservices on the level of the software itself, but we also have the entire networking structure, how everything is connected together. Is the network secured? Whether we are using encrypted traffic between all the microservices? There are a lot of different questions. I'm neither a QA expert nor a security expert, so I don't think I'm prepared to give like the best answer for that. But yeah, definitely focusing on both lower level testing at the microservice level and then the integration testing is something that we're approaching. Also, one thing that's possible with microservices is a thing called chaos testing or chaos engineering, when we basically randomly try to crash different subsystems and see what happens. And if they crash, we want to make them not necessarily more resilient, but more independent of each other's failures. So if we send a request to one service and don't get a response, we need to handle that gracefully.
Okay.
Finally, with just one more thing, with the microservices also came like new approaches to handling the security of them. So there are ways to make it easier to automate some of the stuff like handling certificates, encryption, and all of that. But this in turn introduces another layer of technological overhead. So once again, we are presented with a question of whether it's all worth it.
Exactly. Thank you very much for this answer. I think that this question deserves a separate talk during maybe next conference.
Oh, yes.
Because it's really broad area. So Piotr, once again, thank you very much for your amazing talk. Thank you very much also for answering all those tricky questions.